I will start to ask our friend Joakim from WSI, who is the event partner for this event, to give us an introduction of WSI and a little bit of the view of sensors. Are you there, Joakim?
Yes, I am here. Can you hear me?
Absolutely. Share your screen, please.
Great. I will just find the right program. So, and do you see full screen now?
Yes, take it away.
Perfect. So, my name is Joakim Sandström. I am a hardware architect at WSI, which is now part of Sigma Connectivity. And WSI, we call ourselves a tech house, which can be translated to a development department for hire. So if you have an idea, we can build it for you. And as the first speaker of this event, I will keep things quite general. Instead of focusing on one specific sensor or sensor type, I will try to dive beyond the buzzword and give you a better general understanding of what smart sensors are and why we have only seen the beginning of the smart sensor revolution. And this is my agenda, what I will talk about. I will start out by defining what a smart sensor is. Then I'll proceed to explain why it is a good idea to make sensors smart. Why not just keep old dumb sensors? I will also give you a brief overview of how you can make a sensor smart, what general principles that are usually employed. I will continue with a real-world example, just to try to tie it all together to show something that you probably had interacted with in the outside world. And then as a final point, I will go through my rationale why I think smart sensors are happening now and why I think their numbers will only explode in the coming years. So what is a smart sensor? Well, it's quite easy. You take a sensor and you add something smart, and then you have a smart sensor. Perfectly simple. But what is smart? Well, apart from being one of the most overused buzzwords in our industry, smart usually means that we involve some kind of software. But software is not always enough. In order to feel really smart, you also need to be able to communicate. So a smart sensor also has some sort of connectivity involved, usually wireless connectivity, but it doesn't need to be wireless. And just to make this slightly more complex and add some recursion, we can also add some additional sensors. And there we have it. Now that we have defined smart, we can write out the full equation for what a smart sensor is. A smart sensor is one or more sensors with some connectivity and some software in between that makes intelligent decisions. And here I give you a generic block diagram for a standard smart sensor. This is more or less all there is to it. One or more sensors, CPU, and some connectivity. And feel free to steal this if you ever need to whoop out a quick block diagram of a smart sensor in the future. Moving on, why should we make sensors smart? Why are we not satisfied with ordinary connected sensor? Why go through the hassle of adding connectivity and software to a sensor? One reason is to generate better data. By combining information from more than one sensor, what's usually called sensor fusion, we can get better insights than from just looking at one sensor in isolation. But some of you may say, why should we do that sensor fusion inside the sensor? Why can't we just sample everything and send it to the cloud and let the cloud sort it out? The problem with that ties together with the next point, and that is that if you have a sensor or a lot of sensors, you want to reduce data transmissions. And there are several good reasons for why you want to keep your data transmissions low and why you don't want to broadcast all data to the cloud and instead take care of some of the processing in the sensor. The first reason is that data transmissions cost money. especially if you're not on your own network. If you use some kind of cellular network, then data transmissions can be a significant part of your operational cost. So for that reason alone, it's usually good to keep transmissions down. But even if you have your own private network, say you have like something like a Wi-Fi or a Bluetooth network, you should still consider data transmissions a bad thing, because data transmissions consume bandwidth. So in situations where you have quite a lot of sensors, for example, in a factory or in a warehouse, just having hundreds of sensors blurting out whatever they see when they see it will most likely congest your available frequency band, and you will have dropped packages and broken communication as a result. So always a good idea to conserve bandwidth and reduce data transmissions for that reason. And a third final reason is that data transmissions cost power. And this becomes especially important for battery operated devices. Data transmissions are usually several orders of magnitude more power hungry than doing some local processing. So if you can do local processing to lower data transmissions, that's always a better option than to just send it straight away. How do you make a sensor smart then? Well, I would say there are many ways to do as smart as a sensor, but there are few basic principles that I would like to outline. The first one is the age-old engineering principle of filtering. And you can do low-pass filter, where you calculate a mean value inside the sensor and only send the data sparsely. Very good for things like temperature sensors. You can go the other direction, do high-pass filtering. Only send data when you see a significant change. And you can combine them to do some sort of bandpass filtering, where you rarely send the mean value, but you also send values if a significant change happens. A good application for that would be like a temperature sensor inside a fridge. You only need to report the temperature quite seldomly, except if something breaks and the temperature drastically shoots up. Another way to make sensors smart is to use something called sensor fusion, when you combine data from several different sensors to get an even better understanding of what's going on. And a classic example is to combine information from both an accelerometer and a gyroscope to calculate movement. Finally, we have a quite new principle that only sprung up in recent years, and that's something called inference. Inference can be described as the act of drawing conclusions. And here we usually employ some sort of machine learning. And common examples here are anomaly detection, when you have a device that monitors some heavy, expensive machinery and looks at a multitude of signals. And instead of streaming all those signals in real time to the cloud, it makes some sort of inference from the data to get out a single health variable, which it can either send at a slower update frequency or only send where the health variable is out of the ordinary when something bad is happening. Another common application of inference is image recognitions. Like if you have a surveillance camera, you can configure it so that it only sends pictures when it sees a human. It doesn't stream everything. It doesn't stream as soon as it says motion, because it might be an animal or something. It selects to only send data whenever it sees a human. Then we'll take a quick example, and I will use the humble home automation motion sensor as a really, really basic example, just to try to drive home this point that the smart sensor doesn't need to be very, very advanced. They are used to automatically control lights in your home. And even though they at first glance doesn't seem to be that smart, they have a quite clever algorithm here to control when they send data, because the goal of these sensors is not to provide better data, it is to conserve power. And they use their smartness to maximize battery life by reducing data transmissions, as we talked about before. The way they do this is that first, they only transmit something when they see a change, when they see movement happening. And secondly, even if once they've seen movement, once they've made a transmission, they have a timeout that prevents them from sending data more than one time every second minute. So this could be a perfect example of bandpass filtering the data. You only send data when you have a significant change, and you never send data too often. And with these smart algorithms, you can get several years of battery life from just a few coin cell batteries. Moving on, why are smart sensors happening right now? What's the reason why everyone suddenly starts to talk about smart sensors, and why do I think that they will only continue to explode in the future? I think it comes down to advancement in 3 key areas. And the first area I would like to highlight is the area of low cost and low power connectivity. You see it in personal networks like BLE, Zigbee, ultra wideband. You see it in local networks with OpenThread and Amazon Sidewalk. And you see it in wide area networks like NB-IoT, LoRa, and the big elephant 5G. A different technology area that also drives through the development of smart sensors are energy harvesting. And then I'm thinking primarily of solar power. We have these 2 very exciting companies in Sweden called Exeger and Epishine, who build these ambient light, very, very efficient small-scale solar cells. And the third point I would like to highlight is what's called edge computing, which means that you push some of your computing resources from the cloud down to the edge of the networks, i.e. the sensors in this case. And we have more efficient machine learning algorithms that's geared specifically towards embedded systems, not only cloud anymore. That's very good to know, that machine learning on embedded is now something that's happening in the real world. It's not just theoretical anymore. And there are 3 very interesting companies that I would like to give a shout out to. It's Econo, Imagimob, and Edge Impulse. They all have a unique take on embedded machine learning, and I strongly recommend you to look up what they're doing and if they can help you. And as a final point, we're now starting to have microcontrollers that have dedicated hardware accelerators for machine learning, which makes machine learning in a better world even faster and less power hungry. And that was everything from me.
Wonderful. Wonderful, Joakim. Thank you so much. I think that was a very nice and very pedagogical way to explain what we talk about today. And it turns our whole event into more like almost like a wine tasting session. So because now we're going to see how the different wines, the beauties we have with us, how they compare to the rules and standards and so forth. Thank you so much, Joakim. And please unshare your screen.